what we're going to do is we're going to take our whole unit pretty much, and we're going to put it together. So we started off with just the modeling, and then we went into the quadratic inequalities, and now we're going to put those two ideas together. So just to refresh our memory, where the model reaches a maximum or a minimum, a highest or a lowest point, what we do is we calculate the vertex. And remember, as part of calculating the vertex, we use that formula x equals the opposite of b divided by 2a. And that's going to come up here in a little bit. Where the model hits the ground, or it hits the water, or the total time an object was in flight, what happens on this one is we have to find the roots, which you may be more familiar with as x-intercepts. And we do that by factoring. And we can also sometimes use our graph to help us solve there. And then finally, where an object was increasing or where an object was decreasing, where it was going into the air, where it's falling to the ground, then we have some sort of interval that we use. And what we're going to add today, though, is how long was an object above or below a certain point. So we'll look briefly at a former example. On day one, we looked at this quadratic model. That is modeling when a rocket was launched in the air with that formula h equals negative 16t squared plus 128t. And it says, on what time interval is the rocket higher than 240 feet in the air? Well, what we do, if we want to write an inequality of the situation, is we take the negative 16t squared plus 128t, and it says higher than. And another way of saying higher than is greater than 240 feet. So there's an inequality describing the situation. I personally find it more helpful if we do something on the graph, which is it might help to graph the line y equals 240 on here, and I'll do the best I can. It seems already the board is disoriented, but let's see if I can get a little bit better picture in here. And there's 240. If you look at the scale 10, 20, 30, 40, 50, so 210, 220, 230, 240 is where I put the red mark, that line. And the nice part is if we do put that in, what we can see is that our red line intersects our graph here and there. And what we're going to be having here is that our time is going to be between those 2 points. The point to the left, if we follow it down to our x-axis, is representing 3 seconds. So our time is going to be between 3 seconds. If we look at our point to the right and we follow it down, it's going to be 5 seconds. So where is our graph? Greater than 240. What I also should have done is point out that here's where it's greater than 240. Just trying to move that purple a little bit. It doesn't want to move. The red line wants to move, but the purple, there we go. That's the part that we're looking at. So between 3 and 5 seconds is where we're greater than. Well, we don't have to be greater than. If we look at part B, it says on what time intervals is a rocket lower than 100 feet? So if we write our interval for this space, what does lower mean? Well, it means that we're going to take negative 16t squared plus 128t and have it lower than 100. And we can also illustrate this on the graph. In fact, I find it maybe a little bit easier to illustrate on the graph. So we go and we're going to type, or not type in, we're going to graph 100, y equals 100 here. Luckily, with our red, we actually had specific points on the graph, but we need to figure out that what we're going to be looking at is this portion and this portion, using those values there where the two intersect. And if we go back to our highlighter here for a moment, this says, where are we lower than? Well, we're lower than here, and we're lower than in this portion of the graph. And we're familiar then with writing our inequality. It is that our time is less than 1 second, or our time is greater than 7 seconds. So again, integrating both our concepts, the modeling and then the inequalities. As we flip our notes over, let's try to put it all together here. It says, Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by this function of h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. The nice part here on the first one is that we are going to type this into our calculator, but we want to put in a scale. We're not going to be able to see the picture, and the scale is given to us. So when we start here, we'll pull out our calculators. I already have the equation typed in and probably the scale as well. But we're going to type in negative 16x squared plus 16x plus 480 in our y equals. And once we do that, if you have it in your regular function, you're probably not going to see much. You can see a little bit, but I want to see the whole picture here. So what we can do once we've got that typed in is we can go to Window, and we can fill this in. And what our notes say is that our minimum x value is negative 2. Our maximum x value is 10. We don't have to change that. Our scale for x is 1. We don't have to change that. Then our y minimum we do need to change to negative 50. And our y max is going to be 600. And our y scale is 50. And that's going to give us a much better picture when we hit graph. So there's our picture. So we come over here. Something like that. Nothing fancy. Something like that. First question. So we've got the picture. At what height did Jason jump from? Well, he jumped from right here. Far left of our picture. In fact, let me label it. He jumped. And that value on our graph is 480 feet. And it says, what point does this value represent on the graph? Well, the point that it represents on the graph, it's where did it cross the y-axis? So this is the y-intercept. I do want to point out, what if you're just given the equation? Can you identify that? Look at where the 480 is in that equation. So an answer on a test or a quiz needs to be y-intercept, but where you're getting at is from the c value. Part C. It says, how long did it take for Jason to reach his maximum height? And what we're going to do is we're going to use our old favorite formula, x equals the opposite of b over 2a. So we need to go back into our equation. Sorry about the screen. It is really acting up right now. But a is negative 16, b is positive 16, and c is 480. And so if we fill in, we've labeled a, b, and c. So we fill this in. So x equals the opposite of 16, which is our b, divided by 2 times a, which is negative 16. If you have a fraction button on your calculator, I would use it. But ultimately what happens is that x equals 1/2. Half a second. And if you prefer, x equals 0.5 seconds. So what is the highest point there? And by the way, again, I left the maximum height in terms of 0.5 seconds if you prefer, because what we're going to do is we're going to take this value and we're going to put it back into our equation, which is going to be the negative 16 times the 0.5 squared plus 16 times 0.5 plus the 480. And I'd like to show you the store button again. If we go back to our calculator, to get out of the screen, remember we can hit second and the mode button. That means to quit. And what I'm going to type in is I'm going to type in 0.5 store x and enter. And then our function, which is negative 16 x squared plus 16x plus 480, and enter. And what we see is that Jason's highest point on the graph is 484 feet. So if we go back and we label here, this is 0.5 and 484 for our highest point. And you can probably guess then what the next question is going to be. Because we have one more value, we could still see it even though I scooted the screen down a little bit. It says Jason hit the water after how many seconds? Well, Jason hit the water here. At that point. And what we need to do in this particular part is we need to factor. And so scoot left on your paper if you're writing this down, because we're going to have to squeeze it in a little bit. It's negative 16t squared plus 16t plus 480. We're going to factor that. But once again, it's really, really difficult to factor when your x squared, or in this case the t squared term, is negative. But we can take care of that if we factor out not only the negative, but the 16. And we get t squared. And we get minus t. Positive 16t divided by negative 16 is negative t. Minus 480 divided by 16 is 30. And now it's much easier to factor. We're going to split the middle. The values that we're looking at are at 30. Sorry, get my English correct. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Will any of those combine to be 1? Either add or subtract. And hopefully we recognize that 5 and 6 will combine to be 1. And it's going to be 5 minus 6 when we split the middle. It's going to be t squared plus 5t minus 6t minus 30. And as we group, I know there's a negative 16 out in front, and I'm purposely ignoring it. But this is t times t plus 5. Watch out, because there's a minus here. And it's going to be t plus 5. Negative 6t divided by negative 6 is positive t. Negative 30 divided by negative 6 is positive 5. And we get t plus 5. And we get t minus 6. And I hope that you can look at this and say t equals negative 5 and t equals positive 6. But if you can't, and it's t plus 5 equals 0, and it's t minus 6 equals 0, and we subtract 5 from both sides, we get t equals negative 5. And we get t equals 6. Negative 5, positive 6. When we solve the factoring, the negative 5 is not an answer because time cannot be negative. So our answer ends up to be t, our time, equals 6 seconds. The thing is, we did that by hand, but could your calculator have helped you find that? If we pull it back up on our screen here, we look at the picture, and we count 1, 2, 3, 4, 5, 6. That's where we hit the water. So if you have a good graphing calculator, that makes a difference. But lastly here, it says, on what time interval is Jason higher than the cliff? Write an inequality that illustrates that. Well, we're going to take that and we're going to say negative 16 t squared plus 16t plus 480. Where is he greater than 480 feet? If we go back and illustrate this on the graph, we're going to get a picture of something like this. Ooh, I'm a little bit off, but you get the idea. So what we want to know is this value right here and that value right there. Because when we draw in our highlighter, it's going to be that part. Should have used a different color. Oh well. In other words, it's going to be that our time is in between two values. We know one of them. It's going to be after he jumps. And the way we get our other value here is we can come into our calculator and we can type in y equals 480. And you can't see it very well in this picture. But what we want is we want the point to the right in our picture. It shows up better on our drawn in picture. We want this point to the right. So what we're going to do is we're going to have to use second, trace, intersect. I'm going to go a little bit closer, but not too close because we know the calculator doesn't like me very much. Enter. It's going to jump over to the second, and I'm not going to move it at all. I seldom move it on that. Third time, so I'm going to hit enter for the second one. Then third time, hitting enter, is jumping right there. See how that kind of goes to the left? And what we see when we look down below on our screen is we see a 1. So we're going to end up with Jason, not T, but 1, between 0 and 1 second. is there. Now this last one here, I'm just going to have to fill it in to finish our the video. But when you look at this one, it says, when is he below? Well, it's going to be negative 16t squared plus 16t plus 480 is less than the 50 feet. So while you're writing that down, I'm going to cancel out that 480 and just put 50. And there's a 50. What we're looking for here when we shade this in is this value right there on the calculator, and then when is he below, and it's going to be between here and here. What's this point there? Well, I know that the end value, which is when he hits the water. When does he hit the water? At 6 seconds. And then I need to figure out what that one is, and it happens to be that it's at 5.7. And the way that I got that, even though I'm running out of time here, is second trace intersect.